Welcome to the third lecture of our Agentic AI series, in which today we are going to cover a very important topic called as memory for Agentic AI applications. But before starting the lecture, let me show you a very frustrating experience, right? So let's go to our VS Code terminal and start our simple customer support agent. Python app.py. Yeah, it has started. Let's give it a prompt. My order number is, let's say, 4321. What is the status of my order? It has given some response. Now let's give it another prompt. When will my order get delivered? Now let's read the response. I'll be happy to help you with that. To provide you with the most accurate delivery estimate, I need to check the status of the order. Can you please provide me with the order number? As you can see, these are two very important words. Order number. As you can see, we have already provided the order number in the first prompt, but it hasn't stored that order number and it is again asking the order number, which is a very frustrating experience, right? I think so you can relate. So now let's begin the lecture. So what is the role of the memory? As I have already explained you and also experienced you, the memory is an essential component that enables agent to store and retrieve the critical information, right? It allows agent to maintain context seamlessly during ongoing transaction. And the role is endless for the memory, right? It is very easy to understand. Now, there are mainly two types of memory, that is a short term memory and the long term memory. The short term memory stores the conversation that is happening in a particular chat history, in a particular chat window, not history, chat window, right? Now, let me explain the mechanism of the short term memory. It is called the sliding window. The short term memory is stored in the mechanism called a sliding window. Let's say, assume, this is assumption, let's assume a human response and AI response corresponds to one token. It doesn't correspond to one token, but let's assume human response and AI response correspond to one token. And our context window has a size of three tokens. That is, it can store only three tokens. So as you can see, the context window is currently full. One token, second token, and third token. Now, what if you are again prompting the, you can say, agent? Now, what will happen? Now, the context window will shift below, right? As you can see, we have again prompted the agent, and the context window has shifted. It has forgotten the first prompt, first user response, and first AI response, right? For example, if in the first response you have written my name is Ria, and in the fourth response you ask the agent what is your name, what is my name, so it will give you bogus answer or it will tell you I don't know, right? So in this mechanism short term memory has been stored. Now we have covered the short term memory. Now comes the long term memory, and as the name suggests, long term memory or persistent knowledge store, you can use interchangeably, enable agents to store knowledge and experience over extended period, drawing on historical information to inform future actions. So what is stored in the long term memory? That the data that is prone to not changes. For example, does your name change in 10 years, right? Probably not. So it will be stored in the long term memory. Do me a favor, open your chat GPT and ask him your name. It will tell you, but you haven't, but in the context window, your name is not stored. How can it tell? Your name is stored in the databases. For example, vector databases or SQL or what database your agent is using, it is stored on that database, right? It can give you personalized experience, robust implementation, and real world application. Let's read this. A healthcare monitoring agent might retain long term data on a patient vital signs, enabling it to detect long term trends and alert providers. Very simple, right? Now let's read the last topic of this lecture, which is management and retrieval. Now, effective retrieval is very important for your agentic AI application. For example, I'm asking my agent to tell me what is my name, and it is telling me that my age is 20, right? So the retrieval is happening. The data from the database, the retrieval is happening, but the retrieval is not efficient. The data I want, it is not giving me that data. It is giving me some another data. So the efficient retrieval is not happening. Strategic forgetting, right? This is also very important. Let's read the content. To ensure seamless performance and avoid clutter, agents must possess the ability to purposefully forget the outdated, obsolete, or unnecessary detail. For example, in your Vector store, there is some data that is stored. Let's say your order ID has been stored by mistake, or I don't know why, but the order ID has been stored. But that order ID you will use, for example, for 7 days or for 14 days, and for the worst case scenario, let's say for 1 month, right? But after 1 year, you will not use that order ID, right? So the agent should have the capability to strategically forget that data, so that the so that we are so that the efficient retrieval is possible, right? And our cost is also optimized in that case because the storage is expensive. And in these days, you know why. Dynamic prioritization. An e-commerce agent balances long-term purchase history with immediate recent data, ensuring that the product recommendation remains both accurate and highly relevant over time. So the prioritization should be given in the data. So this marks the end of this lecture. I hope to see you in the next lecture soon. Till then, stay safe.